This is the first instance we have reached orbit. Mercury, out there at the forefront of our solar system, is a small, uninhabited planet shrouded in a web of intrigue and mystery. At first glance, nothing appears significant about this planet. However, recent investigations by NASA have unveiled some startling revelations about Mercury that were unexpected. Some of these astonishing discoveries, including data from the James Webb Telescope, have ignited controversy within the scientific community, with many suggesting the possibility of extraterrestrial species hiding on the planet. Amidst the chaotic revelations and bizarre conspiracy theories, a new plan is emerging within the scientific community. It is a master plan to strip Mercury of its bewildering masks and uncover its dark secrets once and for all. What astonishing secrets have scientists uncovered about Mercury? And what groundbreaking plans does the scientific community have for this enigmatic galactic neighbor? Join us in this video as the Webb Telescope finally uncovers what NASA has been hiding about Mercury all along. Our solar system is more than just a collection of planets orbiting in a cosmic dance. Each of the 8 planets in this enigmatic ring system possesses unique features. Although planets like Jupiter and Mars often grab the spotlight due to their remarkable significance, one other intriguing planetary body that seems to be overshadowed is Mercury. Mercury is the planet that sits at the top of the list in order of proximity to the Sun. Its distance from the Sun is only 58 million kilometers, compared to Earth's 150 million kilometers. Mercury is also relatively small compared to Earth, measuring just 3,000 kilometers in diameter. Thanks to its tiny radius around the Sun, Mercury is the fastest planet to complete its orbit around the Sun at an impressive speed of 47 kilometers per second. The planet completes a full rotation in just 59 days. In other words, 1 year on Mercury is only 88 days, or about 3 months on Earth. Mercury's small size and incredible speed are just a few of its fascinating characteristics. From a distance on the cosmic map, it even appears to be a potentially habitable planet. The small planet has always intrigued the scientific community, but for some reason, it hasn't received as much attention as its cosmic neighbors. The first recorded observation of Mercury was in 265 BC. Early astronomers, such as Zupus in 639, also studied the planet. However, the scientific community of those times had only fragments of data due to the use of rudimentary scientific equipment and ancient telescopes. It wasn't until the 1960s that tangible data about Mercury began to emerge, thanks to the efforts of NASA. A few years ago, NASA released the first real images of Mercury to the public. These larger-than-life photographs depicted Mercury as a celestial embodiment of beauty and complexity, but it came at a high cost. Despite years of planning and concerted efforts to explore Mercury, scientists could only get a brief glimpse of it. The reality is that scientists have a hard time observing Mercury like other planets due to its proximity to the Sun. The Sun's intense rays and bright light can damage optical instruments like telescopes if they focus on Mercury for too long. As a result, scientists can only observe the tiny planet for a few minutes at a time to prevent equipment damage. Even the James Webb Telescope cannot point directly at the planet due to its closeness to the Sun. It's quite enigmatic how this relatively small, nearby planet is more challenging to study than the more distant planets, all because of the Sun's temperature and gravitational pull. Sending a probe to Mercury is more akin to a suicide mission than a stellar mission. The probe must adapt to the extreme temperature, atmospheric conditions, and gravitational pull or risk disintegration. It might surprise you to know that Mercury speeds around the Sun at a remarkable 30 kilometers per second. This breakneck speed makes it the fastest orbiting planet in our solar system, which also presents difficulties for spacecraft aiming to survey or land on its surface. So far, only 2 space missions have targeted Mercury: Mariner 10, launched on November 3, 1973, and Messenger, launched on August 3, 2004. Both missions were conceived by NASA and are the primary sources of nearly all the information we have about Mercury today. The Mariner 10 spacecraft conducted 3 flybys, each revealing the crater-ridden surface of Mercury and shedding light on its magnetic field. This spacecraft was equipped with 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer. NASA aimed to gather as much data as possible from Mariner's visit to Mercury. As luck would have it, the probe gradually approached the small, fast planet, and scientists were astonished to see its chaotic, cratered surface, reminiscent of our moon. The images from Mariner were stunning, showing Mercury to be unlike anything experts had anticipated. Besides the rugged planetary surface, the spacecraft detected a weak magnetic field and an unusually large core. Mariner took over 2,700 images of Mercury, providing scientists with a rare and unparalleled view of its fascinating landscape. The second flyby of Mariner 10 was on September 21, 1974, capturing the southern polar region of the planet. The final flyby occurred in March 1975, after which the spacecraft ceased transmitting signals to Earth. Later investigations revealed that Mariner 10 had exhausted its gas supply and could no longer continue its rounds. The remarkable work of Mariner 10 was followed 30 years later by NASA's Messenger, which took off for the nearby planet. Unlike its predecessor, Messenger not only conducted flybys but also managed to orbit Mercury. This allowed scientists to collect more in-depth and intriguing data about the planet. Armed with compelling images of Mercury, NASA sought to delve deeper into the planet's atmospheric conditions and chemical composition. The agency also aimed to study the planet's magnetic field and explore its geological history and planetary core. As expected, the Messenger probe was equipped with all the necessary instruments for this groundbreaking mission. Interestingly, the probe completed 3 orbits around Mercury, capturing around 200,000 photos of the planet. These images were unique because, unlike Mariner's mission, they covered both sides of Mercury. During the Messenger mission, the probe ventured well into Mercury's orbit, hovering about 25,000 kilometers above the planet's surface. This close proximity allowed the probe to photograph both the light and dark sides of Mercury. Upon analyzing the images and comparing them with data from the spacecraft's instruments, NASA discovered that Mercury had unusually high concentrations of calcium and magnesium on its night side. Moreover, the planet's magnetic field appeared strangely distorted, with greater intensity in the northern regions. This odd magnetic field pattern puzzled scientists for years until further research and analysis revealed the cause behind this anomaly. Mercury's peculiar magnetic field is attributed to its formation process. Magnetic fields on planets are generated by reactions occurring in their cores. For example, Earth's core contains liquid iron, which solidifies towards the outer core. This solidification process creates convective currents, generating powerful electric currents that produce a substantial magnetic field extending into space. This mechanism is how Earth's magnetic field lines are generated. However, Mercury's magnetic field operates differently. Recent research led by Ho from the University of California, Los Angeles, discovered that iron transitions from liquid to solid at the outer boundary of Mercury's core, which differs from Earth's inner boundary conversion. Ho explained, "We had figured out how the Earth works, and Mercury is another terrestrial rocky planet with an iron core, so we expected it to operate the same way. But it's not working the same way. It's like a snowstorm where snow forms at the top, middle, and bottom of the cloud. Our study of Mercury's magnetic field indicates iron is snowing throughout this fluid, which powers Mercury's magnetic field." Further research confirmed that Ho's findings aligned with data from NASA's Messenger mission. This revelation led scientists to believe that planets might have multiple ways of generating magnetic fields. Although Mercury and Earth share similar core constituents like sulfur and iron, differences between the two planets can produce remarkable variations in their magnetic fields. The disparity between Earth and Mercury extends beyond their magnetic fields. For instance, scientists were surprised to find that temperatures on Mercury can soar to over 430 degrees Celsius during the day but drop to as low as -170 degrees Celsius at night. This puzzling scenario is due to Mercury's lack of an atmosphere. Unlike Earth, Mercury has a thin atmosphere or exosphere, composed mainly of atoms blasted off its surface by meteoroid impacts and solar winds. Scientists believe that the intense heat on Mercury causes any potential atmospheric formation to quickly evaporate into space. Moreover, without an atmosphere, the side of Mercury facing the sun experiences extreme heat, while the night side remains cold. Here's a shocking fact. One full day on Mercury is actually twice as long as its year. While 1 year equals 88 Earth days, 1 day on Mercury lasts 176 Earth days. This means one side of Mercury is constantly exposed to intense heat and sunlight, while the other side remains in darkness. These two factors, lack of atmosphere and extended daylight, contribute to the extreme temperature fluctuations on the planet. The extreme temperatures on Mercury have long fueled speculations within the scientific community. While having a magnetic field and rocky soil structure makes Mercury a candidate for potential habitability, the extreme temperatures make life on Mercury practically impossible. Nonetheless, certain controversial features of this enigmatic planet have led to questions about the possibility of finding biological life on Mercury. This has raised questions about whether Mercury could actually be habitable, and if so, what forms of life might exist there. So far, the surface of Mercury has proven quite intriguing. Much like our moon, the planet seems to have numerous impact craters. The moon has long been associated with controversies and conspiracy theories about aliens due to its large number of craters, some of which have enigmatic shapes. Although no concrete evidence exists of extraterrestrial moon bases, some have started to speculate about similar possibilities on Mercury. Although impact craters are typically caused by asteroids, it's not impossible that some could be the result of spacecraft. For example, NASA's Messenger probe caused a significant crater when it crashed into Mercury's surface on April 30, 2015. Today, Mercury's surface features numerous craters, cracks, ridges, and even traces of lava eruptions. What if some of these craters were caused by extraterrestrial spacecraft or alien activity? Several other astonishing facts about Mercury have also given rise to conspiracy theories, such as the ice-water deposits found at the bottoms of craters at the planet's north and south poles. A recent scientific study from the Planetary Research Institute revealed that Mercury's north pole might have conditions suitable for extreme life forms. These habitable areas possess conditions similar to those on Earth, albeit hidden beneath the planet's surface. This surprising conclusion was drawn from analyzing images from NASA's Messenger probe, which were used to create a map. Using this data, scientists discovered salt glaciers on Mercury that contain volatile compounds supporting the possibility of biological life. Despite the harsh environment and the planet's proximity to the Sun, experts believe there is a chance that aliens or some form of biological life could exist on Mercury if we dig deep enough. One of the most impressive achievements of NASA's Messenger probe was its ability to create a map of Mercury, detailing all the craters and basins on the planet's surface. This allowed NASA scientists to study the planet's geology in depth. Furthermore, the probe revealed Mercury's surface composition: 43.6% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Scientists also found an unusually high abundance of volatile elements like sulfur, but a surprisingly low amount of iron. This discovery sparked debate within the scientific community because it set Mercury apart from the other planets in the solar system, which are generally known to have higher iron and sulfur content in their ores. Finding a planet that deviated from this norm was unexpected and generated significant interest in Mercury. Recently, scientists observed something unusual about Mercury: a peculiar dusty ring around it. This discovery once again sparked controversy, as many experts were concerned that Mercury seemed too small to have a planetary ring. In our solar system, only Jupiter and Saturn are known for their rings. Jupiter's rings are faint and were first observed in 1979 by Voyager 1, while Saturn's ring system is well-defined and visible even from Earth. Saturn's rings consist of billions of small particles, some notably larger, all orbiting the Sun. The materials in Saturn's extensive ring system include water ice and rocky material. Scientists believe that the rings of Saturn and Jupiter formed during the early stages of our solar system, with the planet's colossal sizes playing a crucial role. Saturn is about 10 times the diameter of Earth and attracted a vast system of tiny rocks and particles, forming its ring system. Jupiter, nearly 12 times Earth's diameter, drew in about 95 moons and created its own miniature ring system. Given the immense size of Saturn and Jupiter compared to Earth, it's understandable how these giant planets could attract cosmic debris and particles with their superior gravitational pull and stability. However, this raises the question of how Mercury, a much smaller planet, has a dusty ring. Scientists using data from NASA's MESSENGER probe discovered salt glaciers on Mercury filled with volatile compounds, suggesting the possibility of biological life despite the harsh conditions. The probe also mapped Mercury's surface, revealing its unique composition: 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium, with high sulfur and low iron levels. This finding generated controversy, and an unexpected dusty ring around Mercury raised questions about its formation. While Jupiter and Saturn are known for their rings, Mercury's ring remains puzzling, with speculation suggesting that meteorite impacts may have created it. Despite its thin mantle and unusual composition, Mercury's mysteries continue to beckon further exploration. The upcoming BepiColombo mission aims to unveil more secrets upon its arrival in 2025, underscoring Mercury's increasing significance in cosmic research.